Good morning, good afternoon, and good evening, everyone. As you probably already know, I'm Tanner Valentine, Director of IT here at AIS, and I want to give a warm welcome to everyone tuning into our third technical development workshop of the semester. The focus of this program is understanding how we can combine the wide use of Excel with the versatility of Python. More specifically, we'll be diving into how we can make the two interact with each other, allowing us to turn unwieldy data sets into formatted workbooks with helpful analysis. As I always say, please feel free to contact me if you have any issues throughout the workshop, since I'd much rather see you get something out of this than just give up because of a small roadblock. Before we get started, I just want to cover some brief announcements that might interest you guys. First off, I don't think I made this clear enough in the last workshop, but these workshops are designed so you do not have to have gone through the previous ones. Obviously, taking the other Python workshops would be helpful, but to get a better understanding of this one, but it's not a necessity. That being said, I will not be covering some of the more fundamental parts of Python in this course. I'll be making references to some previous topics so people don't feel clueless, but if I explain everything, then we'd be here for a year. Next up, keep an eye out for upcoming AIS events this month. We'll have our 8th speaker series, as well as our AI panel on the 29th, as well as our Zumba and yoga event on December 3rd. That being said, I'm sure most of you are more excited just to enjoy your break this month. Lastly, if you enjoy this workshop, or you think it could have been done better, check out Professor Mark Doyle's MIS 3580 class next semester. His class will be covering Python as a data analytics tool using the popular Pandas library. This workshop will give you a taste of what's to come with that class, so please take a look if you're interested. Plus, I should be the ITA for that class, so for some reason you just can't get enough of me, don't worry, you won't have to. Now, let's look at our lesson plan for today. Before we get into any content, I'm going to explain a bit why you should find value in learning to use Python like this. From there, we'll be delving into two specific Python libraries, Pandas and OpenPixel. These are two very commonly used spreadsheet manipulation libraries, so don't be surprised if you see them again in your future job. After that, I'll be covering some tips of when to use each library and finish off with us creating a basic report for the dataset as a class. A lot of the things I'll be covering will showcase individual ways to get things done with these programs. With that said, it's important to realize that there's a wealth of customization available to you in the way you code. It isn't a requirement, but I highly recommend you guys follow along with the documentation for both Pandas and OpenPixel. I'll be adding the links to these websites in the description of this video in case you guys are interested. One last thing. Be sure to follow along with the mid-lesson exercises by accessing the exercise files available to everyone on the AIS website under Member Resources, right when you found this workshop. One thing I've learned about my fellow MIS majors in my time here is that not nearly as many people are in it for the actual hands-on tech parts. And hey, this isn't me passing judgment. I just know we're all here for different reasons. I did want to emphasize, though, how these tools extend beyond software developers and working in dimly lit rooms without talking to people. To begin with, a solid understanding of Excel is heavily recommended, if not a necessity, for anyone planning to get a job in business. With almost 90% of companies using Excel for budgeting, planning, and analysis, there's almost no excuse to not get your hands at least a little dirty with the program. As for Python, even if you aren't programming anything directly, it's being used in almost every industry. This is because of the language's insane versatility, being used for data analysis, web page design, machine learning projects, maybe just about anything under the sun. Also, some of the courses in our major may be switching over to Python to replace other languages, so keep your eyes out. In conjunction, the two are a powerhouse that let you parse through huge or complex data sets, allowing you to save your own time and produce better reports and better analysis. In short, you should really care. Now, let's see a little more of what we have in store today. Pandas and OpenPixel are both helpful tools that serve different functions. As you can see just by the topics planned, all of Pandas is honed in on data, while OpenPixel does a lot more of the aesthetic work that Pandas can't perform itself. While Pandas allows us to move quickly through our data, OpenPixel allows us to present it in a better way for our audience. Because of their differences, it's important to recognize when you should be using each library. Pandas is an absolute data powerhouse. So even though it can be used for all data sets, it's best suited for the large ones other programs can't handle themselves. It works through the information very quickly, but lacks any visualization tools to present the information it gathers. This is where OpenPixel comes in handy. This library cannot handle the large data sets nearly as well, but is fine-tuned to work directly with Excel. This means the user gets a wealth of options when it comes to visualization and formatting of workbooks. Essentially, use Pandas for enormous data sets and analysis, and use OpenPixel for smaller data sets and visualizations. One last reminder, for all these libraries and the functionalities within them, it is a necessity to import the correct packages at the top of your code, else none of the commands will be recognized for that to function. For your exercise files and deliverable, I'll have these imports already set up at the top, but keep this in mind for future projects. All right, now that we have those explanations out of the way, let's get into the thick of it. The first thing to understand about Pandas is that all data is stored in data frames. Data frames are essentially spreadsheets with named columns. It's not too complicated, but you need to keep it in mind. I also want you guys to keep in mind these two acronyms, DF and PD. Since Pandas is a library, you have to import it within Python and give it a name so you can use the functions and methods that come with it. The majority of people will abbreviate Pandas as PD within their code, but just know that you could make it anything you wanted. DF is simply the name that I will be giving my data frames throughout the majority of time throughout the lesson. If you see me writing DF, just assume I'm working with a data frame. When loading files into Python as data frames, there are really two main ways to do it. It's based around what file type the source is. The three main ones are .xlsx, Excel files, .csv, stands for comma separated values, and .txt, text files. For CSV and text files, you can just use df equals pd.read_csv, and then you have to have your file name within the quotes within the parentheses. Make sure whenever you're using any files throughout the exercise of the deliverable, that you always have the file extension at the end of the name, because otherwise it will not be recognized. For Excel, the only difference is using pd.readExcel instead of readCSV, and making sure that your file is the correct file type at the end of it. On that note, please make sure every time you reference a file, you put the full path and file type at the end of it. To make it easier on yourselves, I'd recommend putting your Python files and data files within the same folder, because then you can just write the code just as it is in the slide without having to put slashes and folder names throughout. One tip to check what's in your data frame is to print out df.head. This will show you the top 5 rows of your data set by default, but you can change how many it shows by putting an integer within the parentheses. And then saving your data frames back into Excel or CSV formats is just as easy as loading them. All you have to do is either do df.toExcel or df.toCSV, depending on what file you type to prefer. Keep in mind though, the file name you input is deciding what you want to name the saved file. Before we get into editing our own data, I want to show you guys how to simply select and view columns, cells, and rows within your data frames. To begin, if you want to take stock of all of your columns, you can simply just print out df.columns. This will output the name of each column within the data frame. Now to actually view the data within each column, you can just print out df and then in brackets, quotes, column, using obviously the name you want as your column rather than column. This only puts out the data in that single column though. To access multiple, you just have to put a list of columns instead of a single column. Notice that there are 2 sets of brackets now, one to contain the list as a single item and one to encapsulate the whole thing. If you want to access individual cells within columns, treat the data like a 2-dimensional array. Saying it like that may just make it more confusing for you guys, but that's what's going on behind it. Just put a second set of brackets after the column name and put the index of that cell in there to retrieve it. You can also retrieve multiple cells by doing a slice, putting the starting index and any index instead of a single number separated by a colon. Notice that to get the first value, use an index of 0. For the vast majority of libraries in Python, all indexes start at 0. So to get the third item, you put in 2. Some functionalities that we'll cover are not like this, but I'll be sure to point them out for you guys. For rows, the syntax is a little different. Instead of just using df and then 0 for the first row, use df.iloc and then 0 within brackets. iloc stands for integer location. Within every data frame is an indexed integers on the left-hand side, starting from 0 at the first row, and then goes down. It's what happens, it's added whether or not your data actually has an index row. It's just put there by default within all data frames. But knowing how our indexes work, to get the 5th row, you'd have to do df.iloc and 4. To access cells within the row, however, simply put a comma and the index of the cell you want. Notice the indexes again, how df.iloc 2, 1 brings you to the 3rd row, 2nd column, not to the 2nd row, 1st column. All that being said, how about we hop into exercise 1 now? I encourage you guys to open your exercise files along with me while I work through them myself. All right, hello everybody. Welcome to the first exercise for TD3. Before we get started, I want to point out a few things to you guys. You see up here, we have all of these imports. Don't touch any of this code. If any of you have done the second TD workshop and you had trouble installing the packages, the command prompt, these commands should do that for you. If they don't, and you get any errors and they just won't actually import, just send me an email. I'd be happy to walk through the process with you myself rather than having you have to quit the workshop. That being said, do not change any of this code. You don't need these for every single exercise. It's just I wanted to give you guys all the imports for all the exercises so you don't have to worry about it yourself. 2 more things. One, sorry if I sound a little sick. I've been on the tail end of some type of respiratory infection for a while, but no matter. And lastly, you can see how in the exercise file I give you, all these things are within the same file. Make sure you keep it that way, so then when you are referencing other files or images, you can just put the file name as it's the name itself. Just put if I want to reference users.csv, I'll just write users.csv, because normally you have to write the entire file path, like we mentioned, but just keeping it all in the same file will negate that for you. All right, so let's get on to step 1 of exercise 1. So first we have to create our data frame from users.csv. Let's look at this file first. You can see it's just a bunch of names. They have an ID column too. It's their favorite color, country, their income, and their current debt. These are all just mock data. This isn't anything real. I just use generator to give us a bunch of random information. So anything we find out, it's not actually indicative of any country or money or anything. So this is just mock. So let's create a data frame from that. So we do that by doing our loading techniques. So let's just start with equals. Yes. Let's do users.csv. So that is creating the data frame. Now I want to inspect this. So I'm just going to print out df.head. Now I'm going to run this now, so we can just see that. I have to save it. See, running for a little bit. This might take a while because of the size of the data frame. All right, you see we have For each of our columns, we have a given index column that's made by Pandas that starts at 0. Then our ID column starts at 1. Then we have all the rest of our columns. You can see first name, last name, favorite color, country, income, and debt. So looking good, looking just like our data frame should. Now, I just commented out step 2, so we don't have to keep seeing that every time we print. But now let's just try to inspect the first 10 entries in the favorite color column. So you can see it's just favorite underscore color. So we'll do that by we'll go to our viewing and inspecting techniques. And let's do df. And then do the slice method. Do 0 to 10. And we want to actually see this printed out. So to put it all within a print function. Save again, and right there. So now you can see these first 5 from the last exercise: puce, purple, turquoise, fuchsia, and purple. And these 5 are back here again, the first 10 of the first 10, but then we have these next 5 ones as well. So this gave us the first 10 values within the favorite color column, just because we can reference the last one. Now, let's look at, we look in the 5th row, 2nd column. Normally, it will be 5th row, so 0, 1, 2, 3, 4, 5. It's the 5th row here. And 2nd column would be the first name, because we have this ID column that we have in there. So this would be Amelia. Now, let's see if we can get that ourselves. We'll use iLook for this. Stroke the 5th row, it's indexed at 0, so we'll do that. And 2nd column, do just like that. Now, we're going to print this out. Run again, and we have Amelia because it's the 5th row, 2nd column. They're indexed at 0, so you have to do 1 below to have that included. If you're wondering why we did 10 here instead of 9, it's because in these slice methods, the second number is not inclusive, it's exclusive. I know a lot of syntactical inconsistencies and idiosyncrasies with coding, but it's just the way it is. I'm sorry. But you can see we wanted to get Amelia because it's the 5th row down, 2nd over. We have to do 4 and 1 the indexes, and that gets us to Amelia. All right, so that is the end of exercise 1. You don't need to have all these printed. You can just count them out, keep them, whatever. This is just for your exercise. But yeah, now we'll take it back to the lecture again, and I'll see you guys again for the 2nd exercise. Now that we know how to access and inspect the content in our data frames, let's touch on adding and dropping columns, which is one of the primary ways to interact with data in Pandas. To simply add a new column onto the end of your data frame, do df and then within brackets and quotes, the column name you want, and then set equal to whatever value you want to fill all of those cells. If you want to have different data values populated in each cell, there are a few ways to do it. The simplest way is to just set the new column equal to a list of values. The only stipulation is that the list must have the same length of the data frame itself. You can incorporate existing columns, though, by using different types of operations. This example multiplies all the values in the tax rate column by the values in the income column to generate a new column. This column will hold the product of the 2 values for each row. Now, this last example, I know it looks long and messy, but I promise it isn't as confusing as it looks. To build this tax rate column, we use a lambda function within the values in the income column. In this line of code, X is taking the place of the values within the income column. The program will check the value of income. If it falls between any of those bounds, the corresponding rate is made the new value of the tax rate column. This is one of the main ways to enable conditional logic within Pandas, so you don't have to write down a bunch of if statements instead. Thankfully, dropping columns is a lot easier to do. All you have to do is df.drop, and then columns equals whatever you want. To do multiple, you just have to put in a list like we discussed before. Now, on a quick side note, notice the in place equals true part within the line. This is an example of a flag. These are optional for all of these, but serve different purposes. In this case, in place equals true just makes it so df.drop will save the data frame that way rather than just showing a copy of the data frame with that column missing. It's essentially like a save progress function while working through your code. Next up is one of the keys to data analysis, filtering and sorting. These tools let you push aside irrelevant data and bring forward the stats most important. For filtering, we're primarily going to use the .look feature. This is similar to iLook, except it doesn't use the inbuilt integer indexes. To filter for the data you want to see, simply put the Boolean condition within the brackets of df.look. If you don't remember Boolean operators, they're conditions that come out to either true or false, nothing else. In this first example, the code is only going to bring up the rows where the condition is true. In this case, that means all the rows that have cells in column 1 equals a value. If you want to add multiple conditions, you can do this pretty easily by just putting each condition in parentheses. One thing to know, however, is that unlike regular Python, where you write out the words and or, Pandas uses an ampersand for and the pipe key for or. If you've never used Python and you're coming from JavaScript, you probably won't be surprised, but I don't assume that you guys do know. Grouping and sorting act a little differently, but they're just as relevant. The group by method is what allows us to return results grouped by certain column values. Say you want to find the mean income of everyone grouped by their age. This would use the group by method. Keep in mind, though, the group by method almost always requires that you do some type of operation at the same time. In this case, we're finding the mean. Sorting is less stipulative since all you're doing is sorting your data frame by the values in a column. You can use this method in conjunction with group by or other things if you want, but I didn't want to overcomplicate the example. All you have to do is do the sort underscore values method and put the column name in brackets within the method's parentheses. One quirk about sorting is that it goes by ascending values by default. So to stop this, add the ascending flag and set it equal to false. All right, now let's hop into our second exercise file to get a little bit more used to changing data and sorting. Hey guys, it's Tanner here, back for the second exercise. And now we're going to try a little more with adding and dropping columns and trying to filter and sort them. So we're going to create our data frame again from the same users file. And let's just make sure everything's in order. Check out the head. All right, same as normal. Let's go. Now, let's drop the ID column. That's pretty simple. Drop. And then the column name. So let's see here, it's named ID. And then I'll put in place equals true. So it actually changes like that. Also, make sure every time you do these true or false statements, you keep a capital because that Python actually recognizes as something that's true or false rather than just like a variable that you named true. Okay. So that drops a single column, and then just run this again, head after, so go and see, make sure everything's changed as it should be. All right, you can see now, no ID column, everything just moved to the left. Wonderful. Here, I'll just comment this out. Actually, I'll just keep this one as is. And we're going to create now a new net words column. And we'll just make it a function of two other columns. So we'll just do net underscore worth, but we keep the naming conventions. To df. Just incoming debt, right? Yeah. No, I'll just print the head again because I want to see what it looks like. All right, net worth, and that math looks correct. Yeah, that's probably correct. It looks close enough for me to believe so. All right, wonderful. So we have that. We can find the average net worth grouped by country, sorted by descending values. Okay, that sounds like a lot first, but we'll be able to do this. So let's do df.group by put where's because name of the column. Then we'll get the average of this. All right, guys, part of coding is realizing you're making mistakes. So I just want to let you know that I was doing that incorrectly before. Okay, so this group by function is going to be a little different than the one we used in the slides because we're going to be making a new data frame out of it and grouping essentially two things rather than one. So we're going to group by country. Then right here have net worth. So that's what they're being grouped by, and then we'll do dot reset index to turn into data frame. Now let's print this big heap and see if we did it correctly. Oh, wow. Okay. Wonderful. So I forgot to sort it, just fine. Because we can just add that on, but it works. Congratulations, us. Okay. So let's do dot sort. Let's sort values. By and we'll do it by descending. So descending equals false. And get rid of that. That's incorrect. Now let's try it again. Okay. All right, so that didn't work. We're gonna not try to overload what we have accomplished thus far. We can do these things in multiple steps. So, we're gonna combine step 4 and step 5, and well, it's also step 5. That's funny. We're gonna save the altered data frame. We're gonna set it to a new variable first before we add the sorting option. Okay, so df2 equals that. So now we'll just do print df2.head. And yep, looks good. So that's the new data frame. And we can just sort values. Oh, nice. Okay, so they're sorted in ascending order. I believe I can just change that. And then it should go, yes, to descending order. Okay. So wonderful. We take this out of here. And we're just going to set df2 equal to this. So this change is locked in. Now we have our new data frame. So we're going to save this as a new file. And we can look back at our old slides. So how to do that. Not very hard. Okay, so it is df2 because we're working with the new one. Def2 CSV. We're going to name it x2.csv because this is exercise 2. And that should do that. Okay, so nothing's going to come up to the console. But if we look back, in our folder, we now have this exercise file or exercise data frame. You can see the country and networks columns. They are sorted here by descending order. So this is the it gave us the mean and net worth among all the people with this country tag and sorted all those values. Okay. So with that, we are done exercise 2. And you guys can just resume back to the lecture. Cleaning data is arguably one of the greatest skills to have when it comes to any level of data analysis. This is namely due to the 80-20 rule, which states that data analysts spend 80% of their time acquiring, formatting, and cleaning their data, while only spending 20% of their time doing any actual analysis. One principle in every data frame you should practice is to have a unique identifier for every piece of data. Otherwise, the data frame can get messy and confusing. In a case where the regular integer index isn't sufficient or just isn't descriptive enough, you can manually set a column in your data frame to act as the new index. This would be perfect for some type of customer database where each client has a client ID or something like. To do this, simply use the set_index method on your data frame and put the column you want as your index within the parentheses. I added in place equals true just so I can type less things overall. To use your new index, use the df.log feature that we used for filtering, since our old ilog feature will no longer be accurate to our data. Another foundation of data cleanup is eliminating bad data. This might be empty cells, not a number values, or anything that doesn't fit where it should. We can replace these values using the df.replace method. This takes the bad value as the first argument, the one you want to replace it with as the second, and you just have to set regex equal to true. I won't delve into this, but regex is just a method for searching for matching values within Python. We'd be here all day if I tried to explain it in depth. Also, as a side note, this method is most commonly used within the NumPy library to get rid of NaN values, which literally translates to not a number. All right, now let's jump into our third exercise and get our hands a little bit more dirty with data cleanup. All right, guys, here we are back with the exercise number 3. We're going to be looking just a little bit at some data cleaning methods, nothing too intense because I didn't want to overload you guys before we hop into the Open Pixel. So we're going to start as we always do and create the data frame from the user's CSV file. And print out tf.head because we want to see what that looks like. To make sure everything is up to par. Yep, everything's looking just as normal. Notice that none of the changes that we did with the other files have changed this because those were saved as different data frames or not saved at all. Let's just console log this out. Now let's set the index because we already have this ID column. So if we already have that, it's working with our customers or whatever this list is for, we might as well set the index to that rather than using the integer location methods. So let's set the custom index. Set index. Then the column name is just ID. But in place equals true. We'll just print head again after this. Yep. Now you see the side index has been gotten rid of, the one that starts at 0, the default one. Now it's just the ID column. So our changes have gone through. That's in part because of the in place function. So that's why we have to do df equals df.setIndex. Now let's replace every country value equal to Canada to Tamriel instead. Okay. df dot place. And then what we want to get rid of is people that live in Canada. And we want to change it to Tamriel. It's a Skype reference if anybody is interested. Equals true. Now, what do we do with all of these? And I hope this has gone through. You can see the man who was once Canada now lives in Tamriel. And I promise you that for the other 1,000 lines, it's the same thing. Because this just goes through every single cell. All right, so now that we have these changes made, we can say this again. To CSV. Look back in our identity folder. And we can see that every single time it should be Canada, it's Tamriel instead. We can just search all these, but we don't really need to do that. So you guys can just believe me. But that's the end of exercise 3. Now we'll head back to the lecture. Let's move on from Pandas and see how we can work with Excel directly using OpenPixel. Unlike Pandas, this library does not use data frames. It can be used directly with Excel rather than just having it as an optional functionality. Now, just like before, I want you guys to get used to these acronyms, WB and WS. With OpenPixel, the majority of your work is done on Excel workbooks or the worksheets within them. But the actual naming conventions are totally up to the programmer. The most commonly used variable names for workbook are WB and for worksheets are WS. So just keep those in mind as we move forward. Let's start with looking at how to make a workbook from scratch. This is really simple to start, since all you have to do is set the workbook object equal to a variable. In this case, we're doing WB equals workbook. Now to set up our worksheet, we want to set WS equal to the active worksheet in the notebook. This lets you start editing the sheet right away. You do have the option though to create new sheets. This just uses the wb.create sheet method, which requires at minimum a naming quotes. If you want, you could also index the worksheet by adding a number to the end. Using the 0 as the index makes this the first worksheet in your book, but obviously you can bring anything you want. If you don't like the title you picked when originally making it, you can always change it with ws.title, and then you just have to set equal to whatever you want it to be. Since OpenPixel just works with Excel, loading workbooks is as simple as just using the load workbook function and putting the name of the file within the parentheses. After you've done all the changes you want to your workbook, you can save it by just using wb.save, then inserting your desired file name within the parentheses. Selecting and slicing parts of a spreadsheet work a little differently than Pandas, since cells are stored as cell objects in OpenPixel rather than just storing values. I'm not going to go too in depth into objects, but think of them as little packets of information. They're not as accessible as the direct values from Pandas, but they let us access the same things with just a little bit more work and can give us more functionality overall. That being said, let's start with cells. To store a single cell, just set a variable equal to WS and then within brackets and quotes, the cell itself. Like I just said, this stores the cell object, not value. To store the value, you can do the same, just write dot value at the end of the cell brackets. We can also store cell ranges by using slices. To get the cell objects A1, B1, and C1, you just have to do WS and then slice from A1 to C1 within the parentheses between the colons. Columns work similar to what we'd expect, except it just stores the cell objects rather than values. To get all the cells in the column, just use WS and then the column name within brackets and quotes. Just like cells, we can get ranges too, using the similar slice method. This way you can store columns A to C by just writing WS and then A in column C rather than just a single cell. One thing about these common row ranges is that they store the object in a two-dimensional array, or essentially a list of lists. When using the previous example, we have to write column range 1 and then 2 within brackets to get the cell object at B3. This is because we need to first go to the second column indexed at 1 and then the third cell indexed at 2. This is because for column ranges, the first index is the column and the second one is the row. Getting individual rows works as we'd expect, just putting WS.1 to get the first row. Getting a range of rows is just as simple. We kind of need to write WS and then the start and row, just like you did with the columns. To get cell B3 in this example, you need to do row range 2 and then 1. Because first you have to go down 3 and then write 2. This is because for row ranges, the first index is row and then the second is the column. One side note I want to touch on is the indexes of the rows within OpenPixel. Even though we are working with the arrays as normal, with indexes starting at 0, you probably noticed that the first row is 1 rather than 0, and then we use 5, the fifth row instead of 4. Some functionalities within OpenPixel have indexes that start at 1 rather than 0. Personally, I'm not a fan of this because it just feels like another chance to get confused, but I didn't make the library. Now that we know how to get each column, cell, or row, how do we change the values within them if we want to? For a single cell, it's very simple. Rather than storing that cell in a variable, we just set the cell in this case A1, equal to the value 1. Make sure though to add the dot value after the brackets, since we need to change the value of the cell, not the cell object itself. Columns get a little trickier though, since they require us to iterate through the list of cells we make. We do this primarily with for each loops. For each loops look sometimes confusing, but all you need to know is that Python is smart in the sense that it knows to iterate through different data types in different ways. It iterates through strings, character by character, through lists, item by item, and so on and so forth. To change all the cell values in a column, just use the for each loop above. You can see that I've written it as for cell in WSC. In this case, the word cell could be anything. It's just that our loop variable that we made. Regardless of the name, the loop will iterate through the list of cells one at a time. To change their values, we just need to write cell.value equal to, and then whatever you want to change it to. We wrote cell.value because we named the loop variable cell at the top of the loop. If we made the variable cow instead, iterate just the same, but we'd have to write cow.value equals something rather than cell.value. Sorry for the mini lesson on for each loops. I just think they used to trip me up a lot. Iterating through a single row can be done the same way as columns, but to iterate through multiple rows, we need to use the iter_rows method. This essentially allows us to iterate through multiple rows by setting maximum and minimum rows, as well as maximum and minimum columns. You can see that there are 2 for each loops now. The first one goes down row by row, and the inner one goes through the cells in each row. Like always, the flags in these functions and methods are customizable. This example allows us to restrict the loop to rows 1 and 2 and only up to column 3. But I encourage you to try other methods yourself. Change the numbers, get rid of some flags, add some new ones. It's all up to you. All right. Now, if you guys could, let's open up the 4th exercise and try out changing some of the values and cells within a workbook. All right, guys, as we go into exercise 4, I just want to let you know that at start of this, we're going to do some pandas before we do OpenPixel, because you can tell that in our folder, we only have users.csv. We do not have a users.excel file. So we're going to use pandas to change that to an Excel file, or create a new copy of one as an Excel file, I should say. So we'll start with all the things we did before. To include the file extension at the end. Then we're just going to immediately go to df.to Excel instead of .to CSV. Users.excel SX. Now, let's just do that. Just going to run that immediately. Now, if we check in here, you see a new users Excel file. So it's the same thing, except now it has different columns. All right, after looking at the Excel file, I don't like that the pandas default index is put into the Excel file for us. So what I'm going to do first is just drop set the index that we have learned how to do before to the ID column, like we did the last exercise. All right, so I want to run that again. Now, let's look at what we have here. Yeah, now we just have the ID column. That's going to be a lot better for our use of this, I believe. Okay, let's go from there. Okay. Let's get into this. All right, so now that we have the user's workbook, we're gonna just load it right off the bat. So I'm just gonna name it WB for workbook equals, and then the users.xlsx. And I'm going to set the WS to be the active worksheet. All right. Now, I want to just print out all the cell objects within the E column. So we're just going to do that by storing that in a variable. So I'm just going to do call E equals E. Then let me just print out. All right. You can see that this just gave us cell objects. There are no values here. It's just going to give us all the E cells for hundreds and hundreds of lines. So that's not really important for us. But you can see that we can do it. Now, let's change all the values in the B column, the B column to, which is the first name, to Rupert, because that's just an awful name. And we can just do that by so you can see that in when we printed out column E, it was like a list of all these cells. So we can do is we can just iterate through them using these loops. So for cell in column E, and we can just do cell dot value equals Rupert. And let's figure out if that actually worked. We can do that by saying the new workbook to a file. Let's do wb.save x4.xlsx or exercise 4. Now, exercise 4, wow, she's right here. You could have never guessed. Let's open it up. And all right. I'm a fool. I'm a fool. For some reason, I decided to do the E column instead of the B column, like I told you to. So if you followed along, look, you don't need to change it because you just have to set another column like this. Call B equals. It's called. Just set it to B and then make it call B instead here. I guess I'll just rerun it. I already changed everything. I don't have to be lazy. All right. Okay, so everybody's name is Rupert, including the column header, because we didn't tell it that not to do that one. So it's going to do every single one. So everybody's name is Rupert. Isn't that awful? It is. But besides, okay, that's all you guys got to do for exercise 4. I just wanted to show you how to reference some of these things. So just get back to the lecture, and I'll see you guys in a second. Before I start explaining some formatting techniques, I want to let you all know that these are single examples of the way to format things. All the flags and values within each line of code here have been decided by me. They are not required. The point of that formatting is that it's up to the programmer. I just want to show you folks how you can format your workbooks. Like I said, these are examples. They are not the way it has to be. Now, let's first cover cell merging. For anyone who doesn't know, merging cells just morphs them into one giant cell. You could use this as a title banner or something in a spreadsheet. To merge a block of cells, you just want to figure out the top left and bottom right cells that you want to be inside the merge cell. Then include them within the parentheses after the ws.mergeCells method. Notice how, unlike other slicing methods we've used, both cells and the colon are included all under one set of quotes within the parentheses. This is just another one of OpenPixel's quirks. Not every syntax is 100% consistent. Unsurprisingly, the unmerged cells method will undo the previous command. Once again, you need to specify the top left and bottom right cells, but beyond that, the format is the same. If you want to be more custom with it, you can also do the merge cells method using flags instead of specifying cells, but that's just an option available. It's not necessary. OpenPixel does also have a slew of ways to format individual cells. Here's a list of some of the most common things you might encounter, like editing colors, text alignment, or fonts. Once again, all of these formatting decisions are up to you. The code does not have to be written like this. When completing exercises in the deliverable, I once again encourage you guys to look at the documentation yourselves so you can find which flags will suit your needs best. One thing to keep in mind, though, is that the majority of colors within OpenPixel are selected by getting their hexadecimal codes. I'd recommend looking up the hex codes of colors you like, but know that 6 zeros really means black and 6 Fs really means white. Besides the available formatting tools, OpenPixel has a cool feature of letting the programmer create custom cell formats. Like I said in the last slide, formatting is all up to you. I'm just going to show you guys how to make a basic highlight style for cells. To start, we're going to initialize the style by storing the named style function in the highlight variable, making sure that the named flag equals highlight. After selecting the font style, I want to create a thick border style to really outline the cells. So I gave it a thick style and made the color black. To save that, I'll store it in the variable BD. Afterwards, I can apply the border style to the highlight style by making all the directional flags equal BD within the border function. Lastly, I make the highlighted cells bright yellow by doing a solid pattern fill and making the color yellow with the proper hex code. Applying the formatting is really simple, actually. You just have to get whatever variable your cell is stored in. In my case, it's called cell, and use the .style method at the end of it and set equal to your custom format. Now let's try some basic formatting tools in exercise 5 to demonstrate what we just learned. All right, guys, exercise 5. Let's get to this. Let's practice some formatting tools. Okay, we're gonna load the workbook as we always do. Exercise 6. That's one we made last time. And set the active worksheet. Now, let us merge the cells L3 to N5, which is not that hard. So do merge cells, and then make sure you keep everything within the one set of quotes for this. L3 to N5. I was going to have us test that, but let's just do everything first and see how it works in the end. So now we can store L3 in a variable. So we can just do that by doing Excel equals yeah, just equals WS L3. Oops. And let's create a simple custom format to apply to L3. I'm probably just going to do the highlight thing that I showed you guys within the lecture. Obviously, you guys you don't have to pick this form. You can make it as simple or not simple as you want. I'm just trying to show you guys what you can do because these are formatting tips. It's really up to the user. Right. I don't really care. I don't know. Just I'll do the bold. I do the border. I'm not that lazy. Right, next, let me add the border. Side styles. Like I said, these are flags. So just not all the flags need to be used every time. They they can obviously have different values and everything. That has 7 instead of 6. Oopsie. And right. And let's just add that fill. Do pattern fill because we don't want a gradient. And we'll just apply it by doing big cell dot style equals highlight. Now let's say this and see what this weird big yellow cell looks like. All right. Let's do that. Do an art. Okay, so now let's just say this and see what this mega huge cell looks like. And we'll just name it exercise 5 or X5. Let's hope everything went off with that hitch. You know she's here. Okay, so these cells merged. L3 is large. I don't know if that order is like that. Just because this is so big or because I messed up. But you know, we got almost there. So maybe I misspelled these things. But regardless, maybe you just don't use the border or use it better than I am. But yeah, that's the end of exercise 5. So obviously all these type of custom formats, they can do anything you want. If you want, you could have just made it, oh, the font is bold, and then just be done with it. Or the color is green. It's really up to you. That's what you get you guys acclimated to this. But yeah, let's go back to the lecture now, and see you guys for the last exercise soon. Once again, while there are some staples to creating these visualizations, a lot of the decisions are up to you. That being said, let's make a pie chart. To start, Just like when you create a new workbook, we have to initialize the chart by storing the pie chart object in the variable that I chose, chart. From there, I have to set up the data and the corresponding labels. For the sake of the example, I'm envisioning a spreadsheet consisting of only 2 rows and 5 columns, with labels all in the first row and the corresponding data below it. To add the labels, we use the reference function within the parentheses. We start by specifying the worksheet we're using, then using other flags to determine the bounds of the labels within the worksheet. Storing the data works almost exactly the same, except I made sure to change the minimum row since we want to get the data from row 2 instead of row 1. Now we add the data to the chart with the add data method. First specifying the variable which is holding our data, in this case is named data, and then setting the titles from data flag equal to true. To set the displayed categories for the pie chart, we use chart.setCategories and just put a labels variable within the parentheses. After that, all we have to do is name our chart and put it in. To name, just use the .title method and set chart.title equal to the name you want. To add the chart, we use the .addChart method and put our chart variable, then the cell in which we want to place the chart. One thing to keep in mind is that the cell you choose is just the top leftmost cell of the chart. The size does not change based on the cell you choose. All right, guys, don't worry, I'm not going to say the same spiel about customization this time. Let's just get into it. Once again, like the charts, tables require you to first initialize them with the table function. You have to decide the display name in the cell references to start. Unlike charts, you cannot reference data with a table and place it somewhere else. You just add the reference cells to the data and the table you place on top of them within the spreadsheet. After that, while it isn't a necessity, I'm going to make a style to add to the table using the table style info function. I chose these flags so I can get some nice stripes in the table to differentiate from each row. To apply the style, we store it into style 2. We used to set our tab.table style info equal to our style, which is in the case style 2. Now, since we can't change the positioning of our table, all we have to do to add the table is use the .add table method on our worksheet and put our table variable within the parentheses. Images are relatively easy to deal with, but do require another import. You shouldn't have to worry about them though for your work since I already handled the imports. We start by setting our image variable equal to the image function. The only input you put in the image function is the name of the file you're bringing in. From there, adding the image simply requires you to use the .addImage method, which asks for an image variable and the top left cell in which you want to place it. If you add the image and you find it's not nearly small or big enough, you can resize them by altering the width and height properties of the image variable. The examples I've shown here are making the height and width of the image 25% of what it originally was. You can use it however you please. Now, let's see a little bit about making charts images within our worksheets in exercise 6. All right, so welcome back to exercise 6. Unlike the other times, this time we're going to make a fresh workbook instead of loading the past ones. So I'm just going to do that and then set the active worksheet. Okay, so you see we have a tiny data set here of just like ice cream type sold, stuff like that. So we want to append this to the new worksheet that we have using the append method. So we can do that. I see we have this is called data, and we're going to do for each loop and just set the row loop variable to row data. I'm just going to say ws.append row, because then for each of these, it'll put this whole row into the data and we'll just put them each by each and it'll basically just fill out the entire book for us. Now, So in this hypothetical workbook, this is rows 1, 2, 3, 4, 5, and 6, and column 1 and 2. So we want to set the variables for this chart that we're going to make to these vanilla chocolate, strawberry, milk chocolate chip, and cookies and cream values. So we're going to do that by, okay, so first we have to actually just like initialize the chart. So we're making a pie chart. So we're just going to do chart equals pie chart. And now we have to add these labels to the data, which is everything under flavor. That's not under salts, everything in that first column under flavor. So we're just going to do labels equals reference here. Do labels equals reference and then worksheet, because that's where she's working in. Then minimum column equals 1, because we're starting at the first column. The minimum row equals 2, because we don't include the flavor word, the cell with the word flavor in it, the label. And then we'll do max row equals 6, because it's 2, 3, 4, 5, 6. And then we'll just do max column equals 1, because we don't want to go into the second column. We just want to get the labels for now. And for the data, we'll do almost the same thing. I'm actually just going to copy this because we're going to change a little bit. So we're going to need this just data. And instead of minimum column and maximum column being 1, we'll make those to 2. So now I'll start the second column, but then still rows 2 to 6. So 2, 3, 4, 5, and 6. So that will put all of our labels and data within these variables for us. And now we can add this data to the chart. So we just do that by doing chart, because we named pie chart. That add data. We named it data. And we'll do titles from data equals true. And then charts dot set categories to the labels that we just got. And let's name it chart dot title is ice cream by flavor. All right, so in this new workbook, it really had stuff from columns A and B. So we're just going to add this in C1 to put it to the right of everything. WS dot add chart. Right, do chart because the variable that we're using is chart. And then I'll just do C1 because that'll be the top leftmost cell within the chart. Now, just to quickly cover some images too. You can see in our folder, we also have this ice cream.jpg file. So I'm just going to set that with an image variable by just doing g equals image, and it's ice cream.jpg. And we'll just add the image. I don't know how big the chart's going to be, so I'm just going to make it as I'll make it F1. Because once again, the top leftmost thing of the image, or top leftmost cell for the image. So now I'll just say this to exercise 6. And let's hope for the best. Ah, my bad. Slider. That all saved. Exercise 6 is alive. Let's take a look at her. Okay. So the image I have is huge. But you guys can see that what's it called? We have a chart. We get all this stuff. We have charts and stuff. We're huge. We have an image. So good job, us. I'm very proud. Now, I'm not saying that. No way. So that's just a little bit on how to get images or charts into your work. A little bit of formatting work. But yeah, that's exercise 6. Now let's get back to the lecture for the last little bit, and then we'll be heading over to the deliverable in just a second. So we've gone through the majority of the content for each library, but I had a few more things that make using both Pandas and OpenPixel a little bit easier. When loading up new data frames in Pandas, you can specify the sheets within a workbook in case you have multiple sheets within one. All you have to do is add the sheet name flag and set it equal to the name of your sheet. This is not nearly used as much, but you can also concatenate data frames, essentially stitching them together at the ends. This does have the potential to mess up indexes though, so be sure to keep track of what your data frame looks like throughout. To do this, you have to use the pd.concat method, and then put the list of data frames within brackets, and then specify whether or not you want to sort it. There's also a few methods to make data frames readable by OpenPixel, since the library cannot normally process them. For this, we use the data frame to rows function, which, surprise, surprise, converts your data frame to a list of rows. You can then add each row to your worksheet by iterating through the list of rows and appending each row. That being said, it would probably be easier just to save the data frame as a new Excel workbook and just access that Excel file within OpenPixel. To finish off the lecture, I just wanted to give you guys a few tips for dealing with large data sets. So let's jump in. First off, I wanted to mention data type casting. When Pandas parses through files to create a data frame, it guesses the data type of every cell it encounters. Sometimes Pandas may get it wrong, but more importantly, it takes time to do this. If you have a huge data set and know which data type each column should be, you can manually cast those columns to the data type before Panda goes through it. This saves time and eliminates possible errors. To actually do this, you just need to add the D type flag when loading up a workbook. Then you can set this equal to a dictionary, which shows the data types you want corresponding to the columns. I'd imagine for some of you that sound like word vomit, so let me clarify. Within curly brackets, put your column name in quotes, then colon, then the data type you want. This should be str for strings, int for integers, and float for floating point numbers, which are just any number that has a decimal point in it. Make sure to separate each column and its data type with commas in between. Another good practice is to replace non-usable values in your code. The most common form of this is non, which literally means not a number. These values have the potential to screw up your analysis, so it's good to replace them with something or drop the rows entirely. To replace, use the df.replace method we used before, but for the first value, put in np.nam. This command uses Python's NumPy library, so the code can search out the cells with NAM in them. You can also simply drop these rows in the df drop method. Be sure to put the indexes of the rows following the label of flight. The last recommendation is just to filter out the data you don't need or drop it entirely. Since Pandas is used with large data sets, the more processing time you can cut out, the better. As someone who has started a program and been able to start making breakfast before it finishes, I truly believe in this one. All right, guys, that concludes the lecture part of this workshop. I hope I didn't make this too confusing for you guys, and I hope the exercises made the information a little more digestible. I truly thank you for getting this far. I'm going to kick it over now to the other Tanner to get you started on the ending deliverable. All right, guys, so you've made it through the whole lecture. For this final deliverable, we're just going to be doing a cool little report, and some basic formatting type tools. So it's going to be up to you, but just follow along with me, and I'll promise we'll get there in one piece. So to start, we're going to, as a classic now, create a data frame for the users.csv file. And we'll just do CSV. Oh, I made a boo-boo. And let's inspect this data frame. That's what I'm talking about. All right, we got that data frame. Good job, us. I'm gonna be doing that a few more times with these next few steps before we get to all the formatting stuff. Okay, now just immediately jump in. We're gonna create a new tax rate column. I'm gonna use a lambda function to decide people's tax bracket. So what I'm gonna do is we're gonna base that based on their income. So I'm gonna say like maybe if they have less than 70,000, they have to pay 25% tax rate. If they have more than that, they have to spend 30% or something. So what I'm gonna do, also, I'm not doing marginal tax rates in this deliverable because this is not a finance class and I'm not doing that math for no reason. So just keep that in mind. So I'm going to create a new tax rate column based upon that. So we have to use a lambda function for this new logic. So df. So keep the naming conventions. I'm more of a camel case guy, but all these are use the underscores. So I'm going to keep it like that. For your sake. We'll do equals df income. And then apply lambda x. So this is where it's interesting because it's kind of as if x is taking the place of the income column or whatever cells in that whatever values in that cell when it's going through. So let's look at some of our common incomes. That's up to like 90 some thousand, probably it's 100,000, probably going down to at least 30,000. So let's do make it 15% if x is greater than 10,000. Just do 0 and 40,000. And then else 0.2 if 40,000. Now it's between 40,000, let's say 60,000. Do that. And we'll just do else 0.25. So we don't need to do a bunch of those. That's just a lot of work. Now let's do our classic print df.head. So everything went through. And wow, let's compare our conditions. Let's make sure everything's going correctly. So it was 25 if they were above 60,000. And then 20 if they're between 40 and 60. Nice, nice. And 50 if they're below 40. All right, there's over here that's below 40. So let's believe in ourselves and believe that it just worked correctly for the rest of them. But, all right, yeah, that's our lambda function. See, it's not actually that hard. It's just you know, just a little tricky reading it first, but we're not going to get too in depth into those. So now we want to like calculate their actual tax. So we're going to make another new column and just name it tax and equal to the income times their tax rate. Tax. And that should be good enough to create that column. All right, wonderful. We got our tax. So yep. Okay, that's working just fine. All right, we're gonna create another column. I know it's a lot. We're gonna name this one net worth. And that'll be equal to df income minus df times debt. And let's do our classic print df.head. I'm gonna get rid of this one too, just so we can only see this one. And look at that, we got a tax, I got a net worth column. Look at that, that's sick. That's pretty dope. All right. So now let's group the data frame by country and compute the cumulative sum of net worth of people there. So this is kind of like what we did with the average thing before. So I'll just put it in a print. I'm gonna do this to start, just to keep it clean for everybody. So we want to group by country. But the actual value, let's have computed is net worth. That's not name. Cumulative sum. Reset index. Now let's print this out. All right. We have an error because I can't spell. Okay. All right, guys. So originally I was doing the cumulative sum method, but that did not work like I wanted. So we're doing the sum method, which is what I actually need to use. So we're gonna print this out again, just to show you. So it's the same format that I had before, except we're finding the sum, and what it's gonna give us is the sum of all people with these countries in their name, all of their net worth combined. So obviously it's quite the lump sum of money. So like France has 14 million for some reason. The US only has 9. Everybody else is, kind of just being drowned by France right now. Good for them. But obviously, like I said, none of these are actual numbers. So we know that this group by works. So let's not print it out. Let's just create the new data frame that is set equal to all this. So actually, I'll name it something better for you guys. I'm going to DF grouped. So we'll say this data frame to a new Excel file. And we'll just name it group data XLSX. Okay. So that's great. It's good for us. Let's see. Group data. Right, here's what we have now. We have these 5 countries and their cumulative net worth with this column right here and country net worth. So that's what we're working with. Let's get back to this. So now with this new handy dandy workbook, we'll load an open pixel workbook with that thing we just made with Pandas. All right, guys, now that we have this new group data in this Excel file, we can make a table out of it. So to make the table, I just named it group table, and I referenced the top left and bottom right most cells of the group data, which I can show you. So you see group data goes from A1 to C7. Close this because we can't run it with that open. Now, I did have some table styles here, but they seem to be running, creating some errors. So you guys don't need to create any styles. You just can add the table, put the variable in here, and using the correct worksheet variable that you have set. Then for step 10, I just want you guys to add one more formatting thing. I'm going to do an image just because I want to. You can do an image. You can do a merged cell. You can do I don't know, colors, anything you want, a chart, table, anything. Just have some fun with it. Just want you to enjoy your time. So I'm going to do python.jpg because I got a picture of a Python, but you guys can do any one you want. Just make sure you're using the correct file name. And then I'll just do add image and G. And then I'll do at, so we're at C7, I'll do it at E1. So now I'm gonna save all this. It probably, I get this error from the tables information. Tables are a little tricky, but don't worry about this. If you get that, it's not, you're not incorrect. So now we'll look at the fundamental. Because of tables, you should ask if you might have a problem. I'm gonna click yes, and it gives me like a repaired version, but it has what we want. It has the table. With the table, you can like have everything sorted, which is kind of the cool thing about them. And then here's my big image. And yeah. So I'm just gonna save that as is. Yeah, and I can just replace it. That's fine. That's mighty fine. So then, yeah, your folder's probably gonna look like this at the end, and then you guys can just submit this this Excel file as the deliverable, and then you're done the third tech workshop. Thanks everybody for coming out. Everybody who complete this along with me. I appreciate you taking the time to look at this just for my own sake, let alone your own informational gain. So I hope this. Hope you like this. I hope if you like this kind of topic, that maybe you come join the MAS 3580 class next semester. But if not, just enjoy your Thanksgiving break and have a nice night, AS.